Hello, welcome to In 5 Minutes. Next is the bidirectional clippers. Bidirectional clippers need to check the positive and negative half cycle for both the diodes. Now when looking at the diagram, considering the first part is this 4 volt. 4 volt voltage source is nothing but reverse biasing the diode because positive is applied to the negative, right? So I am redrawing the circuit. You have the diode, the supply voltage 4 volt and your output voltage. Now positive negative VI, diode voltage here is 4 volts and you have VO. This diode obviously will be reverse bias because this 3 volts is reverse biasing the diode, and the supply voltage will again reverse bias because positive is applied to the negative. So we need not consider this branch in the positive half cycle. We need to consider only the first branch in the positive half cycle because positive is applied to the positive of the diode. So diode will be forward biased, but after some voltage that we need to find out. Now input voltage is given 30 volt peak to peak. That means it is going maximum till 15 volts in positive half cycle and going minus 15 volts in the negative half cycles. Now when you apply KVL in this part, it will be VI plus minus, so minus VD minus 4 is equal to 0. So voltage across diode is VI minus 4. So until and unless we are overcoming 4 volts. Why? Because this is reverse biasing the diode. Positive is applied to the negative terminal of the diode. So diode is nothing but an open circuit. Now, so whatever VI is applied, you are getting at the output. How? When you apply KVL from the input to the output, what you will get? VI minus VO is equal to 0, which implies VO is equal to VI until and unless the diode is open circuited. Now, it is said that you need to assume the diode as practical diode. That means we need to consider the 0.7 voltage drop across the diode. So what will be the equation? VI equals to 4 plus VD, that is 4 plus 0.7, that is 4.7. So VI minus 4.7 is equal to 0. So now we need to overcome the voltage of 4.7. Until and unless we are going above 4.7, the diode will not be short circuited. So initially your VI will be 0 minus 4.7 minus 4.7, the diode is open circuited. Then 1 minus 4.7, it is greater, diode will be open circuited. Similarly till 4.7, the diode is not short circuited. After 4.7, the diode will be short circuited. Though the circuit will look like this, short circuited, you have 4 volts and you have plus minus VO and this 0.7. We need not consider 0 over here because it is told that it is a practical diode. So VO, this is positive, negative, VO minus 0.7 minus 4 is equal to 0. So VO will be 4.7 volt when the diode is short circuited. When the diode will become short circuited once you overcome 4.7 volts. This is the analysis for positive half cycle. Now moving to the negative half cycle. Negative half cycle, now we need not consider this because in the negative half cycle we are applying negative over here and positive over here. That means we are trying to reverse bias this diode and this voltage source is already reverse biasing. So we need not consider this part. Now we need to consider the other part. Now when you redraw the circuit, you have the diode, drop is 0.7 volt. Then you have 3 volts battery and the output voltage plus minus VO plus minus VI. So when you apply KVL over here, it will be VI plus 0.7 and this is 3 volts, that is plus 3 equals to 0. Now VI plus 3.7 equals to 0. Now we are going into the negative half cycle. Negative half cycle, your input will vary in the negative direction. So 0 plus 3.7, again 3.7. When the diode will be short circuited, now this is positive terminal connected to the negative of the battery. That means the circuit is nothing but diode is open circuited. You have 3 volts battery connected across this and the entire circuit will be resistance. You have input, you have output, plus minus VO plus minus VI. So when you apply KVL over here, it will be VI minus VO is equal to 0. That means VI is equal to VO until and unless the diode is open circuited, right? So when the diode will be short circuited when you overcome 3.7. Now next will be minus 1 plus 3.7. So this is how the voltage is decreasing. Once you are reaching 3.7, it will be 0. After 3.7, the diode will be shorted and the circuit will look like diode is short circuited. Voltage drop across diode is negative, positive 0.7. You have negative, positive, negative, positive 3 volts and here you have VO. Once the diode is short circuited, we need to apply KVL from this point to this point. So KVL will be VO plus 0.7 plus 3 equals to 0. So VO will be minus 3.7 volts once the diode is short circuited. When the diode will be short circuited? When you are overcoming 3 plus 0.7, that is 3.7 volt. Now how to draw the waveform? See here, until and unless we are overcoming the voltage 4 plus 0.7 of the diode, we are not getting any output. Once we have overcome 4.7, the diode will be short circuited. When the diode is short circuited, 0.7 plus 4 will give you 4.7. It will be constant. After that, it will decrease. Now in the negative half cycle, you will get the output till 3.7 because the diode is not shorted, it is open circuit. So whatever is input, you will get the output till 3.7. After 3.7, the diode will be short circuited, and when you are applying KVL over here, you will get the output as constant 3.7, and again after 3.7, whatever is the input, you will get at the output, and this cycle will repeat and henceforth. This is how bidirectional clipper works.